So the 3 Python concurrency patterns. Introduction. This is my name. My name is Iyanuoluwa Ajao. I'm from Nigeria. This is my Twitter account, my GitHub account, my technical blog, and my AI-related Substack newsletter. I'm a software engineer and AI engineer. So what is concurrency? Concurrency is when 2 or more tasks run in an overlapping manner. So I have an analogy to explain what concurrency means. Imagine you have two videos, you're playing 2 videos with YouTube. So there is a YouTube video account 1 and the second video. So now you're trying to play the 2. Now, but the difference is you play the first one after it has loaded to an next point, to a point, and then the second one is paused. So the first video, you are playing it because there's enough and it has loaded already. Then the second video, you pause while it is loading, basically. So basically the way it works is there's a pause and play for it to overlap, basically. So the first video is paused while the second one is played, and then the second is paused while the first one is played. So that's concurrency. So that's the analogy I use to explain concurrency. Now, for is when 2 or more tasks run at the same time. So the analogy is now you're playing the first video and the second video, the first YouTube video and the second video. Now you're playing it simultaneously. So there is no need for overlap. So you're not pausing and playing. So the 2 are playing simultaneously. So that's parallelism. So like I said, the first YouTube video is playing while the second YouTube video pauses. The second YouTube video plays while the first YouTube video pauses. So that's concurrency. And then for parallelism is when the 2 YouTube videos are played simultaneously. So that's parallelism. So now this is my definition. Now this works because now for parallelism, it works because there is multiple CPUs. So because there are multiple CPUs, they can run simultaneously. That's parallelism. So that's when you can use parallelism. Now, for concurrency, it is 1 CPU, but there are tools in place for it to run. So yeah, you create. I will explain more about how they work for concurrency, basically. So now, when do you need concurrency and when do you need parallelism? So you need concurrency when it requires CPU-bound problems. So, for example, mathematical problems. So it makes sense. That's when you need CPU and then you need multiple CPUs. Now, for IO-bound is when when you need concurrency when there are IO-bound problems. So maybe, for example, it's a network call. So you need concurrency. So an example was the YouTube video where there are 2 YouTube videos, of course, and then there is network call problem. So because the first one plays while the second one is pausing. No, the reason it is pausing is because it is waiting. So it's buffering, basically. So it's pausing. And then the first one you play, the second one you pause, or the first one you pause, the second one you play, basically. So that's when you need concurrency to be able to manage the 2 YouTube videos playing. Now, so this is normally when you want to run a code for this particular example I'm using, it is synchronously. So because it is synchronously, it will work one after the other. So when the first one completes, then the second one. So an example is, so because we have the 2 YouTube videos, now you need to complete the first video before you move to the second video. So the first one, even while it is waiting, you have to wait. And then it pauses, it continues, basically. So then when you finish the first video, then you move to the next video. So that's synchronously, basically. And then in that scenario, you use the Python request library. So the Python request library is what you use basically. So it pauses on its own, it plays on its own, and you just continue until that number of tasks has performed basically. So in this scenario, it is you have 2 YouTube videos. Now you need to, so after the first video, it is out until after you finish the first video, then you move to the next video, which is one after the other basically. You use the request library. Now, when do we need threading? Now, this is the code for threading to explain how threading works in Python. We use the threading library in the standard library in Python. So a thread is a different flow of execution. The threads are not executed at the same time. There are 2 major differences from the first program. In that now, we now have a thread pool executor. So this creates a thread, a pool of threads that run concurrently, and an executor that manages how the threads run. So in this scenario about the YouTube example, each YouTube video is a thread, and then myself and the executor. So I decide when it pauses and when it plays, and it pauses and plays when there's network. When there is buffering, it pauses or it plays, depending on the network actually, basically. But the threads are the 2 YouTube videos. Now, the disadvantage of it is that it is the operating system that determines when a task is paused and another is played. So shared between threads must be protected. So now, for the example, the analogy I used, which is the YouTube video. So the operating system determining when a task is paused and the operating system in this scenario now. And then I decide when it is paused, when it is played. Now, and if there is the need to share data between the 2 threads, it is risky. So you need to protect the threads so that it becomes thread safe. Now, the next is for concurrency is AsyncIO. So like I mentioned, there is concurrency and then there is parallelism. Now for concurrency, there are 2 libraries that you can use to perform a concurrent task. So the first, like I mentioned, was threading. Now the second is now concurrency and is now AsyncIO. So this is the AsyncIO library in the standard library, and it has a specific keyword for AsyncIO, which is the async, and then you can see the async here, and then you can see the await keyword in now. So now one major difference between AsyncIO and threading is that you need the specific keyword, which is async and await. That is why in that scenario, we don't use request. We use AIO HTTP. So the reason is because request doesn't have async await and you'll be waiting for long. So for now, we just use AIO HTTP. So that's for threading and AsyncIO and concurrency, basically. Now the next, we now go to parallelism. So where we use the music multiprocessing standard library in the standard library, basically. So can you see this is the code? This is an example of running multiprocessing. So now in this scenario, it creates and can determine the number of pulls to create. So in that same scenario, for now in this, it is based on the number of CPUs that you have available. Now, by default, it creates the equivalent for the number of CPUs in your computer. So it is by default because it is based on the number of CPUs on your computer. So now you might now ask, what's the difference between threading and AsyncIO? Because initially we've already differentiated we have separated the difference between the concurrency and parallelism. So where the parallelism is for multiprocessing and concurrency is for threading and AsyncIO. Now for concurrency, now how do you differentiate between threading and AsyncIO, or when to use threading or AsyncIO? most of the time it just makes sense to use, okay, it depends. It will depend. So if there are libraries that implemented async await, it makes sense to use AsyncIO. The reason is because AsyncIO is faster. Not just that, it is less resourceful, paired with trading, and that's it basically. So the benefit is faster. But the problem is that you need to find libraries that have implemented async await. So is why when we use the AIO HTTP library, we needed to use AIO HTTP for async to work. If it doesn't, it will fail. Now, when they are down in a scenario, they say like Poto 3 is from AWS, where they've not implemented async await. That's when you might now need to use trading. So the first time to use, if you make a decision on when to use it, the first thing to ask is there library for async await in that particular task? If there is, just use AsyncIO. Now, if there are no libraries for that, they just use trading basically. So, and that's one of the problems with trade. So it's expensive. It requires RAM, memory. It makes sense to just start with AsyncIO if libraries that have implemented async await already. If not, then you use trading. What are the difference between the multiprocessing, AsyncIO, or trading? So for concurrency tasks or IO-bound tasks, you use AsyncIO and trading. For CPU tasks, bound tasks, you use multiprocessing. So that's how you differentiate when to use multiprocessing or when to use. Thank you for this talk. Have a blessed